Hello everybody, it's James here from Flocode.dev. This video is an introduction to Python for engineers, and this is the first video in the Flocode Intro to Python course, which is a free course from Flocode.dev intended to show engineers just how much they can achieve through the Python programming language. If you're curious about Python and how it can be leveraged to accelerate your engineering career, you're in the right place. So let's jump in and explore this fascinating topic. We'll start with explaining the course, what it is and who it's for. Firstly, no prior coding experience is necessary. This course is designed specifically for engineers new to programming. I will provide a high-level overview of Python and its relevance to engineering. In my case specifically, this includes aspects of civil, structural and geotechnical engineering, but of course these principles will apply broadly to all engineering disciplines. And you're busy, of course, we get it. Flocode's courses are designed to contain the essentials. They're sequentially ordered to give you exactly what you need. And much of the learning within Flocode is based on promoting and instilling programmatic thinking. We're going to learn about the nuts and bolts of Python, but this is a long-term pursuit and it's all about building the momentum you need to continue your own journey. Learning any new skill, especially one as complex and obtuse as programming, it's difficult, and my role in this process is to make that as efficient and painless as possible. So by the end of this course, I want you to understand the value proposition of learning Python and ultimately feel ready to continue your own learning journey. So who am I? My name is James O'Reilly. I'm a structural engineer with extensive experience in diverse multidisciplinary engineering projects worldwide. I have a master's degree in advanced structural engineering from Edinburgh Napier University, Scotland. And over the last 14 years, I've worked on a variety of heavy civil projects in the energy, water, bridge, mining and marine sectors. But over the last 6 to 7 years, I've adapted my workflow to lean much more heavily on Python and other open source tools for a broad variety of engineering projects and tasks, many examples of which I will share later. So before we get into the weeds, we need some context. Python's significance in today's engineering landscape, it's rapidly increasing. It's a powerful tool that streamlines your workflow, enhances data analysis, and opens up new avenues for innovation in design and problem solving. It's still underutilized in traditional engineering settings, but a growing number of forward-thinking firms are beginning to embrace Python. It's very useful in automating calculations, controlling software, generating reports. This kind of thing is becoming standard within many consultancies, and that's demonstrated by Python's integration with a lot of industry-leading software giants like Revit, Ansys, CSI Software Suite, Rhino, and many, many more. The use cases that we explore in the Flocode curriculum are based on my own experience using Python and will provide a broad foundation in the language using many different examples, which will empower you to build your own custom tools that are tailored to your specific engineering challenges and workflows. So what does learning Python actually involve? Well, adapting Python for professional engineering requires proficiency in 3 core areas: Jupyter notebooks, scripting, and building applications. This is a simplification, of course. There is much to learn in the space between these topics, but generally speaking, this is how I like to approach it. And understanding these tools and techniques is essential for learning how to streamline your own workflow and how to solve problems in new ways. But before you can really start implementing anything practically with Python, you do need to do some groundwork in terms of understanding the fundamental syntax or structure of the language. This is relatively straightforward in terms of computer programming principles, but it can be a significant mental workload for somebody with a demanding engineering workload, which is presumably why you may be watching this video. Making the space for yourself to learn Python is a serious part of the process. So let's talk about Flocode's plan for course material. There are many topics to cover and the breadth of possibilities is very wide. As such, the best way to teach Python is through a fundamentals first, principles based approach. We'll cover a diverse range of use cases across different engineering disciplines, offering bite-sized challenges that will help to solidify your understanding with each step. And then as you progress through Python's core syntax and control flow, the complexity of the examples that I share will gradually increase. And this ensures that you're building these skills and fitting the puzzle pieces together yourself. And then as we progress through the curriculum into Flocode's more advanced courses, we'll delve into aspects of structures, hydraulics, geotechnics, data science, automation, and tool development. The list goes on, but rest assured that it is comprehensive and steadily growing. So that about covers it for this quick intro. Next, we're going to talk specifically about why engineers should learn Python and the best way to approach it. Thanks for your time, and I will see you in the next one.